So welcome. Happy middle of December. We are almost done with 2020. Ooh, little party. My name is Whitney and I am a GMAT and GRE instructor here at Manhattan Prep. Tonight's free prep hour, we are going to talk about what we want to notice when we're doing geometry problems, but more importantly than that, how we can use geometry practice problems to help us figure out what we need to learn for geometry. And I'm going to let you in on my secret of my favorite geometry flashcards. And I'm going to spoil the surprise a little bit. My favorite geometry flashcards do not have just like area of a triangle on the front, and then you flip it over and it's a formula. Those are dull. We want more exciting flashcards. So we are going to be working on a bunch of problems. I'll have a timer running. So we're going to be working with pretty standard GRE timing. We are going to look at both of the quant question types, discrete quant and quantitative comparisons. So if you have not done much work with quantitative comparisons, if you're relatively new to the GRE quant section, then we'll do like a very brief intro. But if you'd like a deeper dive into those, we've got plenty of other free prep hours on the channel. So here's the deal about geometry, I find. And just heads up, all the problems that we're doing tonight come from our 5-pound book, which you can purchase from us or on Amazon, all kinds of places, that has thousands and thousands and thousands of practice problems. But everything we're doing is going to come from our 5-pound book. But here's the deal with geometry, is that it's the one place where I think a lot of people are panicked because we haven't seen geometry in a really long time. But it's also the place where people are like, give me the cheat sheet. I'm just going to memorize everything. And I think that's fair, right? We want the cheat sheet. I want to know what all the formulas are that I need to know. That said, the way the GRE tests things, we need to move beyond just memorizing a formula. We have to see when certain formulas apply. And so we're going to do a little bit of all kinds of geometry. We're going to touch on all sorts of geometry problems tonight in the process of unraveling maybe some content that you don't know and that needs a little bit more work. So we're going to like start kind of ease into it a little bit, but we're going to ramp up the difficulty as we go. The reason for that is that I want to make sure that the questions I give you are difficult enough that for at least a couple of them, you'll be able to leave tonight with a flashcard. And so I'm going to show you how to make flashcards for any of the problems that we work on. And so we'll talk a little bit more about that. But without any further ado, we're going to just try a problem. And so standard timing for the GRE for GRE quant problems is about 1:15 for what we're going to call the quantitative comparison questions, and about 2 minutes for what's known as discrete quant. And so discrete quant are often going to be just plain old multiple choice. Sometimes they might be fill in the blank. Sometimes they might be choose all that apply. But the vast majority will be just like your standard 5-answer choice, pick an answer. So we're going to start with one of those. And to that end, I'm going to give you 2 minutes to work roughly. When I'm doing individual problems, sort of my like pro tip for individual problems is to set a timer counting up so that you can just get a sense of how long certain types of problems, how long certain content areas take you naturally. Once you're putting together sets of problems, you'll then start to set a timer counting down for like the whole amount of time. But for a single question, I rarely recommend setting a timer counting down because the timing that we're looking for is kind of a benchmark. You don't have to finish all DQ, discrete quant questions, in 2 minutes. That's the target. So let's get one going. If you've been with me in a free prep hour or one of my classes before, we do some breathing. So take a moment, right? All of the getting logged in and moving around, right? All the studying. So we'll take a deep breath. It's nice to breathe in through your nose. Open mouth, let it go. Right. We're here, we're doing it. Pens and papers at the ready. I will get your timer started. Good luck. Send me your answer privately, so to panelists only, when you think you've got an answer. I'm starting to see a fair number of answers rolling in. Kind of a testament to the fact that this is not one of our hardest questions that we'll ever see. But keep coming. If you haven't sent me an answer yet, no big deal. You still got a little bit more time. Get me one in. All right, here we go. We're rolling into that 2-minute mark. So for a lot of you guys finished in about half the time. Fair enough. First big question to the group. So if you'll change your response from panelists to panelists and attendees, if you don't mind. What are the rules? So what geometry rules did we have to know in order to answer this question? What rule or rules did we need in order to answer this question? Feel free to go ahead and type those into the chat window to me. What rule or rules was required? Ah, nice. So I needed to know the formula for the area of a triangle. And that's it. I only needed the one rule. They gave me a picture, which is awfully nice of them. And then it's a problem that really only involves a single step. It's a single rule. And so if they give me a picture, I'm going to copy it onto my paper. And so I'd sketch it out. If they don't give me a picture, right, my first rule of geometry, if they don't give me a picture, I'm going to draw one. Now, when you're drawing your picture, make sure it's nice and big. So in case you need to add any other notation to it, you have plenty of room. So what is the formula for the area of a triangle? Who can tell me what the formula is for the area of a triangle? Nice. Area is 1/2 base times height. Nice. So that's going to be the second item is as you know it. So as you know them or recognize them or realize that you need them, start writing down useful formulas. So a lot of people will jump straight to just plugging in numbers, and that's fine for some of these easiest problems. But I actually like to say, oh, if I need the area of a triangle, let me put that down on my paper first. 1/2 base times height. And then my lowercase b and h's are pretty awful, so I will often make them capital just to make my life easier. All right, so the base and the height, like the rule I need to know is that a base and a height are perpendicular. So this is our step 3, is to make inferences and solve. So base and height are always going to be the two, are going to be one side of the triangle will be the base. And the height will be whatever the vertical distance is from that side to an angle across from it. That's it. That's all I need to know. And so in our little picture, we've got base of 8 with a perpendicular height of 6. So we've got the numbers that we need. So if I plug these in, 1/2 base times height, I'm going to cancel first. So 6 times 4 is 24. Not bad. I'd say most people got it right. Right. If you did not get it right, you get to make your first flashcard. And so what your flashcard is going to look like in this case is you'll put the question, at least some portion of it, on the front of a card. And then on the back of the card, here comes the really important part. On the back of your little flashcard, you're going to make a note about what you would need to know, notice, or do. Okay, so what did I need to know, notice, or do in order to get this problem right? Or what do I need, I guess, is maybe we'll use the right verb tenses. Right, so that's what's going to go on the back. I'm not going to write those words necessarily, but that's what's going to go onto the back of my card. So if you miss this because you're like, Whitney, I haven't done geometry in a small lifetime, great. On the back of this, you're literally going to write the formula. Area equals 1/2 base times height. So area equals 1/2 base times height. And then you're also going to make a little note to yourself that like base and height are perpendicular, which means at 90 degrees. And you might even need to remind yourself that that little box symbol in the bottom corner means 90 degrees. So whatever information you needed to be able to answer this question, that's what goes on the back. Okay? So the front of my flashcards essentially never has a simple rule on them, ever. The fronts of my flashcards have some portion of a problem on them that signal me to think about certain things. If what you did for this problem was just make a careless mistake, then that's something that would probably need to go into what I'd call like my little error journal. So if you wrote the formula down wrong, you knew it was 1/2 base times height, but then when you started to plug in, you forgot the half part because you didn't write the formula down. Then those are the types of like top level notes you want to make, which is, Whitney, always write the formula down first, or always do your math on your paper. So whatever the reason you got it wrong, if it's related to some sort of content or strategy, that's going to go on a flashcard. If it's related to some sort of just like mechanical mistake, read too quickly, kind of got a little bit arrogant and didn't actually write anything down, that kind of thing, those will go into like an error diary or an error journal where you start to collect how frequently you are making the same little mistakes that you wish you would stop making. All right, so let's try another. We'll take a deep breath. All right, good luck with this one. All right, so a little slower on this one, which would indicate that maybe these are some rules that some of you would like to brush up on, which is great. What rule or rules do I need to know in order to be able to answer this question correctly? So what content do I need to have loaded into my system in order to have been able to answer this question correctly? So I always start there. What's my content? You can type that to me. What content? And in the process, you can tell me what the actual formulas are for any of the content that you think I need. Yeah, so I need area of a circle. They're talking about area of a circle. And I need circumference of a circle, whatever the heck that is. Nice. So I'm going to write my formulas down. So the area of a circle is pi times the radius squared. Lovely. And the circumference of a circle is 2 times the pi or 2 times the radius, r. So another way to think about circumference is pi times the diameter, which the diameter is just double our radius. Okay, so I have my formulas. I might still draw up my circle, just have a little sketch so I make sure that I'm like, okay, that's what I'm doing. I'm doing a circle here. The radius is this thing. That's my missing piece. That's what I need. And so from this formula with the area, so I'm going to say the circle has an area, 16 pi equal to pi r squared. Divide both sides by pi. We also need to know that approximation, 3.14 if you don't. So I divide both sides by pi. I get 16 is r squared. And therefore, we only worry about positives in most of our geometry. So r is going to be equal to 4. So our radius is 4. I'm going to plug that back into my circumference formula. So this is 2 times pi times 4, or in other words, 8 pi. So my correct answer is B. If you chose A, lots of folks chose A. If you chose A, the question is, what did you miss? Right? Did you just find the, pi r instead of 2 pi r? Which of these formulas needed some work, or was it that you didn't write stuff down? So you can take a moment and put at least some of the details of this question. Oh yeah, so many people are like, I just cannot remember the circumference formula. See, exactly. So this becomes a moment to say like, I'm going to put this question on the front of a card. And on the back, I'm going to write the formula for area and the formula for circumference. It's a much more effective way of learning formulas than just forcing yourself, like, when I see area of circle, I think this. Practice this material in the same way that you're going to see it on test day. You're not going to have very many questions that just say, like, what is the formula for the area of a circle? Far more often, they're going to say things like exactly what we're seeing, is that those things in use. All right, so we're finally going to try what's called a quantitative comparisons problem. The answer choices are always the same. I've got them posted down here in the bottom right corner for you. But just so you know, what you're trying to accomplish for a QC problem is you are comparing quantity A and quantity B. Be careful, right? Be careful. This information that's up here, this triangle and this rectangle, are the same information for the whole problem. So any information at the top applies everywhere. But what you're doing is trying to compare the values in these two quantities and decide which one is bigger, or if you can't tell which one it is. Our goal time for these is about 1 minute and 15, so take a breath. Good luck. All right, so answers were a lot slower on this one, and a lot of different answers this time. So again, you can go ahead and fingers at the ready. What are the formulas or rules that we need to know to be able to answer this question? What do I have to know? What do I need to know? Okay, I do need to know some algebra. I love that. Yeah, I need to know how to plug in and simplify expressions. That's a big one. And I definitely, geometry wise, the formulas for, or the kind of fact about the sum of the interior angles of, of, of shapes. So the interior angles of a triangle add up to 180 degrees. And the interior angles of a quadrilateral, four-sided figure, add up to 360 degrees. And so I could sit here and solve. I could say, all right, this is 4b equals 360, and this is 3a equals 180. Or if all of the angles are the same in a triangle, it's an equilateral triangle, which means all the angles are the same. And so I want to have an equilateral triangle memorized. So I know right away that this is 60 without even having to go through the steps. And an equal angled quadrilateral, they're all going to be 90. Every angle is going to be 90. And so B is 90, A is 60. And so I'm going to plug in. So 2 times 60 plus 90 compared to 3 times 60 plus 90 over 3. So 120 plus 90, 180 plus 30, and they're the same, 210 and 210. The two sides are by definition equal, so the correct answer is C. If you weren't sure of either of those rules, flashcard. Put as much of this problem as you think would be helpful. Plugged random numbers. You mean like picking anything I want for A and B, period? That was luck. That was luck. You're never going to need to, you're always going to need to use the information that's given. You're going to want to use the information that's given. Okay. All right. Let's do it. Let's try another. Let's start to kind of keep moving on some topics. Let's try another area. Take a deep breath. Good luck. All right. So I think I did it. I did it. I'm excited. I came up with a problem that was definitely on the harder side, huh? Have I hit a content area that some of you folks are like, okay, now I'm stuck. I don't remember. What are the rules? What do I have to know? What are the things? Like what? So always start with the information. What information did I need to be able to answer this? From that, we'll then decide like what strategy should I have applied, but just flat out, like what information? Okay. So the first thing I need when I see coordinate geometry, which is what this is, I do need to think about the equation for a line in what is known as slope intercept form. Y equals mx plus b. And the reason they call this slope intercept form is because m is the slope of the line and b is the y-intercept. And y-intercept is literally a definition for where the line, or where whatever this line is that I'm working with, crosses the y-axis. So that's going to be right here. Slope, if things go up from left to right, then that's said to have a positive slope, because if I were to draw a little one over here, because it's got a positive rise over run. So I go up in a positive direction, I go over in a positive direction to get from one point to the next. This is what they mean by rise over run. So for the example that we've got on the board, in order to move to the next point to the right, so let's call this point down here, I don't rise, I actually fall to run, which means I'm going to have a negative slope. Okay, so things that go up from left to right, no matter how flat, as long as they're not perfectly flat, any little bit up from left to right is going to have a positive slope. Any little bit down or steeper will have a negative slope. The more steep it goes, the more positive. The more steep in a negative direction, the more negative, big negative numbers. So if this is a y equals mx plus b, what I know now is that I need a formula that would have y equal to a negative something, negative slope, times whatever the x value is. Notice my answer choices have x's in them. Plus b is going to be this pink up here. It's going to be positive. So I'm going to have some sort of positive constant down here on the end. So right now, I don't have anything fully in y equals mx plus b. Not quite. We'll start with the first three. To get the first problem into y equals mx plus b, first I have to move this 6x by subtracting. So 6y equals a negative 6x plus 7. Negative 6x plus 7. And then I'm going to divide everything through by 6. And I get that y is equal to negative x plus, and I'm just going to call this 7/6. This looks pretty good. This would be a negative slope with a positive y-intercept. So I would stop there. However, just for practice, we're going to look at what these other lines would look like. So b is almost there. I'm just going to divide everything through by 3. B is y equals negative, 4/3 x minus 1. We're close. We have a negative slope, but we would have a negative y-intercept. This line would look like this because it would cross the y at a negative point. Cross the y at a negative point. The third one down, I'm going to move the 10 by subtracting it. So 5y is equal to a negative 4x minus 10. And so y is equal to negative 4/5 minus 2. This is the exact same problem that we had with b. So we have the negative slope, but also a negative y-intercept. So the intercept will be below the what's called origin. The last two are lines that usually mess people up. These are horizontal and vertical lines. So the line of y equals 2 is a line where every single value on it would equal the y value would be 2. And so y equals 2 is going to be a horizontal line that crosses on the positive side. X equals negative 2 is going to be a vertical line that crosses where x is -2. So if we kind of assume that this point right here is -2, then this is the line for x equals -2, vertical line. And so the correct answer is, in fact, A. There, right? There goes a lot of information that you might need to be able to answer this question correctly. You have to know how to graph a line. You have to know the y equals mx plus b. You have to know how to rearrange answer choices, right? And so the algebra behind that. So there are a decent number of pieces for this problem. If you didn't get it right, the front of your new flashcard should be this problem. Right? And just like a sketch of at least one or two answer choices. Just one or two answer choices. Yeah. And then you'll put on the back, what's the stuff I needed to know? And then what's the stuff I needed to do? Like I needed to write down y equals mx plus b. I needed to analyze what positive versus negative meant for the slope, what positive or negative meant versus the intercept. So take a moment. I want you to start to sketch this because I got a lot of folks missing this one before we move to our next problem. So yeah, exactly. Perfect. All right, let's do another. Right, beginning to sketch out some flashcards, just enough of one to get you started so that when, this session is over, you can make some more of them. So let's try another one. Take a deep breath. This one's DQ, so our target time is about 2 minutes. This one seems like it might have been another doozy. Good. I'm glad. I can put some on. I don't have very many answers in. And so if you have not gotten me an answer, then give me something. Because even on test day, you'll want to put an answer down for everything, even if it's just a guess. And you can say guess. You can totally say guess. Absolutely fine. I got answers in from a few folks. If you've sent me an answer, what rule or rules do I need to know? What rule or rules do I need to know? Ooh, I love the I guessed. And I've already seen it on another video before, and I still had to guess. That says that, it could stand a little review. It should be on a flashcard for you. I need to know the area of a square I need to know the area of a circle, but now we've stepped this up a little bit because area of a square is one thing. Area of a circle is another thing. But I also have to know how they relate to one another. Like I have to connect them somehow. And yeah, there's the other piece that the diameter of the circle, maybe this other color, it's easier to see. The diameter of the circle is the side of the square. And great, the radius is going to be half that. Yeah, exactly. So the square has an area. Well, what is the formula for area for a square? What's the formula for the area of a square? It's side squared. So I'm just going to call it x squared. And we already know the area of a circle, which is pi r squared. And we know that if this side is x, then r is half of that. All right, well, we'll start with the area of a square. That's x squared. That equals 50, which means, what in the world is x? That's not a pretty number. What's x? I don't know. I'm going to take the square root of both sides. And here's the beauty. I'm going to leave it alone. X is the square root of 50. I'm not going to mess with it. I'm not going to try and simplify it. I'm just going to leave it right alone. Leave it right alone. Okay? And we'll see what happens when we just leave it right alone. Next, I'm going to see that the radius, right, if this side length is root 50, and I'm going to draw it on it, then this little piece right here is the square root of 50 divided by 2. So that means that's my radius. The radius is the square root of 50 divided by 2. I'm going to plug that into the area of a circle formula. So this is pi times my radius. Keep everything all wrapped up in parentheses. Squared. Notice I didn't have to do anything fancy with the square root. It's going to turn out to just cancel itself. So once I square it, I'm going to get pi times 50 over, don't forget to square both, 4, which is 25 over 2. So this is 25 pi divided by 2. Is there another way? Because sure, if I knew all the formulas and I knew how to connect them, but this one might warrant a little asterisk on your flashcard on the back. And this one might warrant a flashcard even if you got it right. How do I know for a fact that the answer can't be C, D, or E? How do I know that for an absolute fact? The answer cannot be, not even possible, C, D, or E. Forget doing any of the math. Without doing any work, I know that the answer can't be C, D, or E, which is fun because a lot of folks picked D. How do I know? For a fact. Ah, nice. So I had a couple people just mention, if the area of the square is 50, so the area of the square itself is 50, then the area of the circle has to be smaller than 50. So I need an answer that's smaller than 50. So I need to be able to estimate pi. That's one of the ones we have to know. So pi is equal to 3.14. So 25 times 3.14 is way too big. That's over 75. I need a circle value that's under 50. Under 50. So that one's out. 50 times 3 is 150, right? Way too big. And then this is 625. This one's a weird one. I might, you can grab your calculator and sort of plug it in there and say like, okay, well, what is 625 divided by 20? It's like 30 times 3. It's going to be really big. This will also be really big. But this is the beauty of divided by 6. Let's see, 625 divided by 16 is 40, basically, times 3. Yeah, it's too big. Way too big, way too big. 25 pi is going to be 75, bigger than 75, but it's going to be about 75 divided by 2. This one's going to be that same number divided by 4. And you could literally throw this in your calculator. So if I wanted to actually get pretty specific, and I'm going to use eyeballing estimation, so here comes my little calculator. I'm going to take 25, I'm going to multiply it by 3.14, and then I'm going to divide that by 4. If the area of my square is 50, the circle would appear to be more than half. More than half. So I'm going to need an answer that's over 25. And I can kind of prove that. Ready for an estimation? If I break a square into 4 squares, notice that the circle is extending past the halfway point of each of these squares. So the square I just drew, this weirdo looking square, what's inside of that is half the area of the full square. Okay? So if you ever draw it that way, what's inside that little square is 1/2 the area of the big square, because it incorporates half of this block, half of this block, half of this block, and half of this block. So my circle is going to be, if I want to get really advanced, my unknown circle area has to be between 25 and 50. And the only answer choice that gets me there is B. So even if you weren't entirely sure what to do with all the oh gosh, what's the formula for the area? Estimation can get you there. And so I'm seeing a lot of, I did all the rules right, but I chose the wrong one because I dropped this one number. I forgot it. And I had a great question that turned up that was like, I know so many of these rules, but I keep getting things wrong for silly mistakes. How do I fix that? And so, I was mentioning you got your flashcards for content or strategy that you didn't know or didn't know how to apply yet. I like to keep, again, a little error journal, and I keep a little small one. It's not big. I mean, it's the size of my little, eyeglasses cleaner, but I keep a little bitty journal, and in it, I will just jot down the lesson of why that careless mistake happened. And so I don't want you to ever think oh, I just need to stop making careless mistakes. That's not an actionable goal. What you need to be saying is, okay, I made this careless mistake because I didn't write all the pieces down. So it's not enough to just say I did it too fast. What part specifically did you do too fast? Did you, in order to move quickly, did you just not write stuff down? What didn't you write down? You failed to write the formula down, right? You didn't draw the picture back down, whatever the case may be. Did you try to do the math in your head? Did you answer the wrong question? So you didn't double check to make sure you understood what the question wanted, the area of the circle. So instead of just saying oh, I make all these careless mistakes, because that's what we all say, because I said it too. What I want you to think instead is, what were the causes of the careless mistake? So what steps did you miss, skip, ignore that then led you down the path of the careless mistake? Oh no, got the answer, but still froze. I was oh, I don't know. Okay. We'll do another quantitative comparison. So again, we're trying to decide which quantity is bigger. Take a deep breath. All right, so typical time for QC, we'd like to keep it under a minute and a half, possible. Got a few answers coming in. So I know that the interior angles of a triangle, well, be careful about thinking that this is too easy. So if the interior angles of a triangle are 180 degrees, then it means that this angle, and this angle are 180 degrees. But I don't know this angle. And I'll be honest, I don't even know how to get this angle. I mean, I could start making up letters. Okay, all right. So I'm going to pretend this angle, we'll call this angle Z. And so like so Z and this angle are all going to be 180. So now I have like a bunch of variables running around. Oh, and then this question mark and this question mark together are 180. But it's like, oh my gosh, that's so many pieces. That's so many pieces. So I do need to know all those rules. But maybe what was missing in this one was a QC strategy. So this is a great moment to sort of ask at various times, did I get the question wrong honestly because of content, or did I get the question wrong because I missed a strategy or a technique? The last one you might have gotten wrong both because of content, because you didn't have the rules, but then also because strategy, you weren't comfortable estimating with given shapes. So the thing we might be missing on this picture is the fact that the big triangle, this one, this whole little piece up here, this whole piece and this piece and this piece together are 180. So 70 plus X plus Y plus, let's call this a thing again. So if 70 plus X plus Y plus Z, if that's 180, and I know that 70 plus this whole big missing piece would be 180, then 70 plus X plus Y is going to be smaller than 180. So to see it another way, if this triangle, if the Y wasn't just this little piece, but the Y was this entire piece, X plus Y plus 70 would be 180. So I'm going to call it X plus, we'll call this like fake Y, plus 70 equals 180. So X plus my like fake Y would be 110. But my fake Y is smaller, or is bigger than my real Y, which means that the sum of these two angles actually has to be less than 110. So quantity A will always be smaller, at least by some amount, than 110. And so the correct answer, the larger side, is quantity B. So be careful. I often find when people are like, man, these are so easy, I got through them so quickly. Be careful. Right? Careless mistakes are just like begging. And QC is a big one for careless mistakes. It's very, very easy in QC to make faulty assumptions. All right, we're going to try one more. And I really like these kind of QC ones. This will be a good one to practice. This is a great one for making a flashcard. So get your notes for this current one in case you'd like to make a flashcard of it as a reminder of how to estimate. Right? With QC, I just need to know which one's bigger. I don't always have to have the actual answer. Yeah, and we do. We have a couple of I had a great question in the window asking about QC in particular, and we've got great strategies for QC. And in fact, we have quite a few free prep hours already on the channel that cover QC strategies. I just did one like a month ago on cheating off a beat, but there's a bunch of QC strategy lessons, so hours of them for you to check out. All right, well, let's take this one. Take a deep breath. Last but not least, here we go. I'll let you guys run a little bit longer just because it's a hard topic. But this is one of my favorite images to put on a flashcard. So there's this really cool rule that when we draw a circle, and we can kind of cheat off of B. When we draw a circle, and inside of that circle, we put a triangle. Okay, so if I were to draw a circle, I'm going to use a different one. If I were to draw a circle, and inside of that circle, I inscribe, meaning touching the different sides, I inscribe a triangle. You know, half the time it's like, who knows? Let me get a different, like a slightly weirder triangle than this. Like, here we go. I don't know a lot. There's not a whole lot I know in a situation like that. There is, however, one really, 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 really special case. And that case is that when a triangle is drawn inside of a circle, and one side of that triangle is the diameter, meaning it goes through the center, the angle across from that triangle is 90 degrees. Now, for many of you that are used to QC, you might have seen this and thought, oh, that's not going through the diameter. You know, it might not be, I don't know, I can't trust my eyeballs because stuff's not drawn to scale on the GRE. And so I need to say, you know, I need to pick something that would be like D. Right. But here's the deal. This rule works either way. If I know that one side of the triangle is the diameter, I know that the angle across from it is 90 degrees and vice versa. If I know that a triangle has an angle of 90 degrees, then I know for a fact that this line is the hypotenuse is the diameter, which means, right, that if I've got this piece right here, right, my hypotenuse is going to be twice the radius. So if this is the radius, this would be the radius too. The right triangle is inscribed in a circle with an area. So we know our area formula. Pi r squared is equal to 16 pi. Cancel the pi's. R squared is 16. R is 4. Then the hypotenuse of the triangle in centimeters is 4. Or sorry, it's 2 times 4 is 8. And so the two are equal. The two are equal here. You could cheat off of B. In fact, Patrick, this would be a place where you could say, well, if the hypotenuse is 8, then each side of this would be 4. And if the hypotenuse of the triangle is 8, then each side of this would be 4. And so what would the area of the circle be? Yeah, it would be 16 pi, 16 pi. But I think for this one, you'd have to know the rule either way. So it could work either direction. Great question. So Allison asked an amazing question. If, no matter how beautifully they'd drawn it, if this little guy wasn't there, and so they just drew a triangle, even if it looked like a right triangle, if they didn't either give me the right triangle symbol or they didn't put a dot at the diameter, right? Like, so that I knew that this line went through the center of the circle. If they didn't give me those two things, then it would be D, because I would have no idea. Well, it would be D because the diameter would either be, this hypotenuse would either be 8 or smaller. So it could equal 8 or it could be smaller than 8. It could never be bigger than 8. Couldn't be bigger than 8. Okay. Yeah. All right. So what I'd like, and we would know that BC is not a right triangle. If they didn't show you the little right triangle symbol, you don't know anything. It could be a right triangle. They're just not giving it away. They're just not giving it away. So your goal, right, particularly when working on things like geometry, I often find that doing geometry problems can be a nice way to check in on what rules I do and don't know. I certainly would get a hold of a book and look through, find some of like your main triangle circle, quadrilateral formulas, right? Start to read about them, start to study them. But I would quickly move from just like simple formula flashcards. Like once you've kind of memorized the formulas to the best you think you have, I would then move very quickly to these more like recognition flashcards. They'll get you a better understanding of the information and they'll let you practice this material the way you'll see it on testing. All right, folks, it's been a pleasure to get to work with you this evening. I think one of our last prep hours of the year. 2020 is almost over. Look at us go. Your next steps, if you have not done so already, you are more than welcome to access a free practice exam on our site. And so you just need to go to the manhattanprep.com and follow the instructions for getting to the GRE materials. Pretty easy to follow. Same, if you go to manhattanprep.com, go to GRE /classes/free. You are welcome to sit in on any of our session ones for our full course for free. So you can come and see some of our other QC techniques are awesome. You can also get a free access to some of our Interact lessons where we've got great QC strategies in there as well. But that's all I have for you. Thank you so much for coming around, friends. It's been a pleasure. It's been a pleasure. I don't see any messages in the Q&A. And so I guess we've taken care of it. Thanks all. I hope you have a wonderful and happy holiday season, whichever holidays it is that you are celebrating. Even if that holiday is just that 2020 is almost over and we're almost there. We've almost done it. We've survived. All right, my friends, have a lovely evening. It was a pleasure to get to work with you. Come back and see us soon.